We're on.
Okay. Probably the slide can be moved, yeah. So could you move to the next slide? Yeah. Probably it's not full screen. I'm not sure if full screen or not. Yeah. And next one. Okay. Yeah. Okay. So yeah, my name is Konrad. Yeah, I am the CEO of the ULAM Labs. Yeah. Together with me is Łukasz. Yeah, our blockchain engineer. We'll be talking about the security of the Web3 applications. Yeah, and possible hacks. Yeah, and how to prevent them. Yeah. So today, basically, you can learn how to look at your decentralized app from the security point of view, how to find and classify all potential attack surfaces, and how to design your application to prevent or minimize those attacks. Yeah. And the agenda, yeah, today plan looks like that. Yeah. In the part one, Łukasz will be talking about the smart contract security. In part two, I will be talking about the infrastructure security, and on both parts here we'll be talking about we'll be talking and providing real life examples, yeah, with the explanations and the good practice how to avoid them. Yeah, and I think we can start. Yeah, yeah, Łukasz will be first one. Yeah, so I'm muting myself. Thanks.
Yeah, hi again. I'm Luke. And by coming here today, you made an excellent decision to save millions of dollars on your next D-app project. And with smart contract security, it's always best to learn from others' mistakes because they can be very costly. I believe it's the first time since online payment processing where application code actually controls that amount of funds that we see in the smart contract world. And the thing is, smart contracts are up 24/7, no downtime. The funds can be gone at any instant. And well, you'll learn why smart contract security has been all the rage with audits and how to protect it as best as you can. So let's start off with a bit of a warm-up at the very beginning with Mount GeoX, the big hack. And well, for those who don't know what happened, well, I hope a lot of you do, but for the not so OGs, the exchange got stolen. It had over 600,000 Bitcoin stolen. And what's very interesting about this is that this didn't happen overnight. And this attack didn't even take 1 week or 1 month. These Bitcoins have been gone missing for a few years. And only then someone has noticed. So this has been, and I believe it will be, the biggest hack in terms of Bitcoin stolen, like denominated in Bitcoin. And here, there's I want to introduce a little mathematical concept called the invariant. And the cool thing about invariance in mathematics is that it's something that never changes. And when you think about the Mount GeoX, let me propose to you some simple invariant that would have totally averted this problem. So here you can think that the sum of all balances on the exchange should be equal to Bitcoin holdings. And well, this makes it much easier to test and audit your smart contract code if you think just a little bit differently. And now what happened to Mount GeoX? Well, it's been a long time ago, but it's easy to imagine something like this happening inside a smart contract where just money goes missing over time. And in fact, it did happen with Compound. And someone only noticed this attack after $80 million worth of Compound have been stolen from the smart contract. And well, in case of Mount GeoX, it could have been just a simple invariant implemented and checked. In Compound, well, the hack also wasn't very difficult. It was just like a single missed calculation. Next up, we got reentrancy and the famous, or should I say infamous, DAO hack. Well, it was very controversial at the time, not really because of the hack itself, but because of the aftermath. We all know Ethereum Classic, that was the result of actually a smart contract bug. And here, what is reentrancy, if you're not familiar with the term? It basically means that you're able to call the same smart contract from within itself or within other smart contract. So let me give you a simple example. You're withdrawing money from a smart contract, and then it gives you a callback so you can do your own bookkeeping. However, you're going to abuse this feature and you're going to call withdraw again before the smart contract was able to update its own state and therefore withdraw the same ethers again and again and again and just continue doing this. And well, in the older Solidity version, it was like pretty much impossible to see some of these edge cases. Now the environments have evolved and a lot of new blockchains actually prevent reentrancy at all. And it's like, for example, Aptos or Cosmos, all these blockchains don't even allow this sort of the thing to happen. I believe reentrancy has been the bane of all EVM chains. And this is especially big with flash loans, where you can take all of the assets of a given smart contract. And well, nowadays we have ways of dealing with this, but it is a serious, serious risk if left unchecked. Another big hack, actually starting a series of big hacks in 2022. A lot of these were on Solana, which was a pretty new environment to build in. And well, the thing you have to know about Solana was that it is very, very bare bones experience in programming. You don't really get a lot of framework. You don't really get a lot of safety assumptions like in Cosmos. It is a much more barren environment to work with when you're developing smart contracts. And because of these reasons, it's one of the biggest hacks of 2022, actually the biggest hack happened, and it was the wormhole exploit. So what happened here was the attacker was able to fake a signature from a VAA from wormhole and mint their own wrapped ether on Solana. And how this happened was that they did not steal any private keys. No, of course not. It was really just a simple replacement of a special account that goes in with a transaction to the blockchain. And this little issue has actually been patched in the official Solana crate on crates.io 4 months before the exploit happened. So, well, really, this is actually shows that if you would compile the smart contract with the new version of the library, you would see that there's this major issue going on. And well, this shows how important it is to be up to date with the new releases and updates in the community and the software that you're building with. And well, the attacks I'm showing here, they were not that sophisticated either. The wormhole exploit was really just an abuse of 2 lines of code. So 2 lines were just wrong. They should be fixed. And this is really doesn't require you to do any crazy, sophisticated multi-layer transactions, but you can just find one small if inside the smart contract code that is faulty. And this issue, it was apparent in more than one smart contract that was exploited in 2022 on Solana. Here we have other examples. One of the biggest ones was Cash.io and Prema Finance. Well, with Cash.io, which was a decentralized stablecoin, very similarly, the attacker was able to replace the account going in with a transaction and supply their own worthless coin and just mint as many this decentralized stablecoin as they wanted. Now, this also wasn't that crazy of a hack because here, really, if you look at the code and analysis of this situation, is that, well, it was actually two if statements that could have been different, which would have totally avoided this hack. So really just like 2 lines of code out of maybe 1,000 that were wrong. And it resulted in pretty much all the TVL gone. And similar thing happened with Crema Finance, which is a concentrated liquidity AMM. But here, you know, when you have those little ticks and the concentrated liquidity markers like Uniswap V3, if you're familiar with it, the liquidity is placed in those little slots. So, and in Solana and Crema Finance, this tick was each stored in a different account. So the attacker found out that you can actually supply a different account. And again, there was one check missing to see if this account is valid. And because of that, again, the attacker managed to just take a lot of fees under fake tick and just go away with $8 million. It's important to note that Cash.io and Crema Finance were not audited at the time of the hack. And the last one here is Tinyman, which was a decentralized exchange on Algorand this time, but a very similar situation happened. So basically here, the smart contract allowed you to withdraw from a liquidity pool. Let's say you have USDC and Bitcoin. And there was like a little quirk inside the code which allowed you to withdraw when you're removing liquidity, you're burning liquidity. You could remove Bitcoin and Bitcoin. So you just say, hey, I want to withdraw 1 Bitcoin and 31,000 Bitcoin, or whatever the price was at the time. And the smart contract, yeah, right. So $3 million in assets got stolen, and other $3 million were frozen forever and cannot be recovered anymore. And it's important to note here that Tinyman was actually audited by one of the top auditing firms, and they are very reputable. And it still slipped through the auditing process. And well, we wouldn't actually know if this issue was implemented after the changes were made, after the first audit report, because, well, there have been some critical issues in the Tinyman exchange before the audit, which have been fixed. And we don't know if it was just missed in the review or it was introduced with the fixes. So here, I want to actually propose an auditing strategy that avoids these issues and brings your chance that the smart contract is secure to the highest possible level. First of all, let's start at the very, very beginning. The smart contract auditing process starts with the quality of your code, the review and testing. Now, I couldn't stress this enough. It sounds very intuitive, but I've seen many, many different times this actually not being the case. And the goal of code review and testing is that you have a smart contract code, which is actually where you have thought through all of the architectural changes and designs that you need for this application to operate. And now, if you supply, let's say you potentially take this smart contract, which is not finished, to an auditing company, you're not going to get enough value because you're paying money for the smart contract, for the smart contract audit. And should the smart contract be in a poor shape or poorly designed, you're just going to get back information about all these issues. And the important thing to know when you're going into the audit is that it's only valid for the specific code hash or a GitHub hash. So only for this one specific commit, the audit is valid. So if you make any significant changes or any changes at all, really, the audit doesn't apply anymore. So it's really, really important to get this first part right. So if you have just one developer working with the code, the biggest value for money you can get if no one else can review the code, is hiring a freelance auditor. And this step is really by far the cheapest way to find major or critical issues with your smart contract code. I don't want to talk about this too much. It can be done, of course, as the code is being finished. I want to point out that this approach with multi-step auditing process doesn't actually slow down the release, because right after the freelance auditor, of course, is going to work with you all the time. It's not like you have to wait a specific amount of time for the report. It's going to come, the bug reports are going to come as you work on the smart contract. And the next step would be to work with a smaller auditing company, especially one that has a unique set of skills, especially coming to the niche you're working with. So for example, if you're working with Algorand, you might want to hire an auditing company and leverage their expertise inside this environment, especially if it's a niche auditing company. And now you do this smaller company audit because you're going to get much more flexibility in terms of times and pricing. And this is very important, that you have one audit done, and then the second one, as we've seen with Tinyman, another audit probably would have saved this smart contract. And once you have this first audit, you can actually go into production. So this process that isn't slower than the original one, where we see a lot of companies just go for one big audit, spend all of the money in one go. I don't think this is the right approach. I believe it's better to just keep some flexibility. And then after this is finished, you can go for the big, well-known, reputable company to put this stamp. We know it is important to have this information on your website when you're building a cryptocurrency project. And then not only you're gonna have this stamp, you're actually gonna sleep better knowing that your smart contract is, in fact, secure. One more thing I want to discuss as a little bonus is while working at ULAM, I've had a lot of different smart contract designs. I've done many of them. And because of the ways we've been testing and producing our code, we've been able to build over a dozen smart contracts. And those which have been audited didn't have any high or critical vulnerabilities. So that's been a pretty great track record. And one of the crazy great ideas that we've come up with was micro contracts. And I want to introduce this because it's been very particularly interesting to me. And the idea here is that if you have a certain smart contract or a set of smart contracts, you're not gonna mix logic and assets together that don't work together. So, for example, let's say you have a farming smart contract. What it does is locks user funds and in turn gives them some rewards. Like standard farming, you give liquidity tokens, you get some protocol rewards or something else. And here, a lot of smart contracts are based on the basic synthetic staking, which is like 60 lines of code. And with this, it looks pretty secure. It's fine. But if you're gonna add some more features to your farm, like rewards for longer stakers, etc., you're gonna run into this scenario where users are putting money into one place and your smart contract has 1,600 lines of code and it's not really using these funds except for withdrawals. And you're putting all of this money at risk without really any need to do so. You just want to lock them. And it just takes just one line of code that is wrong or one missing check and all of this money is gone. So this is why each user could simply have an escrow account. And this is especially convenient for low gas blockchains where the gas is cheap. And you just create an escrow account for each user. And this escrow account locks the money and updates the farm. Simple as that. And now what you've done is you have moved all of this assets as risk into a smart contract, which only the owner can interact with, as like 10 lines of code long. So you can audit just this small part of code. And then you can supply as many lines of code that you want into the farm, because the only funds at risk are the rewards themselves. So you don't even need to audit the main farming application, because the assets at risk are very low. So I love to see new modular smart contracts, especially with the new EIP diamonds. And well, I hope to see more modular smart contracts on the Ethereum network. And because it's easier, first of all, easier to audit, easier to read, easier to make sure all the logic makes sense. And one more convenient thing, you can make safe flash loans without worrying about reentrancy if you put the flash loan smart contract separate from the main application. All right, and with these words, I want to finish the part about smart contracts, but it's not everything that will make your DApp secure. Thank you.
Yeah, thank you, Łukasz. Okay, let me share my screen with the slides. Yeah, can someone confirm? Łukasz, can you confirm that you see slides?
Yeah, it works.
Okay, great. Yeah. So, okay. So my part will be about the infrastructure security. Yeah. Yeah, smart contract is not the only one attack vector. Yeah. When we check the history of the hacks, yeah, for the last, let's say, I don't know, 10 years. Yeah. We can definitely see that there are many hacks done on infrastructure itself, not only on the smart contracts. Yeah. We can compare, probably we could even compare like the amount stolen, or even amount the number of the attacks. Yeah, it could be even it could even exceed the smart contract ones. Yeah, so yeah, this is obviously important area to check. Yeah, and yeah, so basically this is, yeah, now you can see like how a typical infrastructure of the decentralized or centralized application looks like. Yeah, with many parts. Yeah, some parts could be missing. Yeah, here, but I think it covers most of the scenarios. Yeah, so yeah, on the white squares, yeah, you have a typical component starting from the browser, yeah, that the user is accessing the user application. Then you have a DNS, yeah, content delivery network, a front end, back end, blockchain if you host your own node, yeah, or it's outside, if not, yeah, it's outside of the infrastructure, and then you have a build system. On the right, you have all possible attack vectors, not all possible, yeah, but most common, let's say, that you should take care, yeah, and watch out. Yeah, and in the next slides, I will be going one by one, yeah, and explaining them and giving examples. So let's start with the first one, is cross-site scripting. It's quite common attack, was quite common attack in the times when the PHP was the main language, yeah, in the Web 2, yeah, before the crypto. It's possible, yeah, in more sophisticated ways. But to understand it, yeah, if someone haven't heard about it, yeah, so the most common example is like, let's say you have your application, there's a user can post a comment, yeah, for something, yeah, or there's a forum and someone can submit a post, yeah, or topic and then post, yeah. So what we should do is that after the user submits the comment, yeah, when we render this comment, we should escape the content, yeah, so that the user won't that is not able to inject the JavaScript into the browser, so that it will be executed on all users browsers. Yeah, so this is the most common attack. Yeah, it doesn't happen in these days because we have a modern framework like React. Yeah, and those frameworks, they auto escape all the variables. Yeah, so there's nothing to worry about in most of the cases. But when we are doing something custom, yeah, well, like in this example here, the Wallet Connect, yeah, this was a bug in the Wallet Connect protocol. And what happened is that they were doing something custom, and they had to take a variable from the URL and put it into the script, and they probably, as far as I was able to understand, they rendered it, the JavaScript in the backend, yeah, with that variable, and that variable was it came from the URL, yeah. So you could prepare a specific URL, someone could click on it, yeah. In the URL there was a script that could then be executed when the user clicked on that link, yeah. But obviously the bug was discovered before being exploited. Yeah, but it shows that the cross-site scripting attacks are still possible, yeah, and the crypto or Web3 applications are still you still can do that on those applications, yeah. So you need to watch out on here. Yeah. So next one is the entries modification. Yeah, mostly in DNS. Yeah, let's call it like a DNS hijacking. Yeah. So here the attack looks like, yeah, someone takes your DNS entries here, change them, yeah, and point to the fake website. Mostly, it's quite hard to make this happen. Yeah, Cream Finance, yeah, was compromised, yeah, a couple years ago, and they said that this was their DNS provider was compromised. Yeah, in the way that the employee did that, yeah, or someone else. Yeah, I don't believe on that one. Yeah, I think that in most of these examples, I will be showing them more in the next slides. Yeah, it's like their credentials probably were compromised, yeah, or they were sharing DNS credentials, yeah, with, let's say, I don't know, marketing team, yeah, because they were preparing some advertisement URLs, etc. Someone could just change those entries, yeah. There was no logging, yeah, 5 or more people were sharing the same credentials, yeah, and then after the attack, yeah, nobody was able to point out who did that, yeah. So that one, yeah. The next one is the injecting npm package. Yeah, obviously, it's not only about the npm, it's not only about the Node.js. Yeah, this could happen in Python, on Rust, or any other language. Yeah, the Node.js and npm is the worst probably environment, like because because there are many dependencies. Yeah, basically. So if you are building a front-end application or desktop JavaScript desktop application, yeah, the dependency tree is really large. Yeah, so yeah, in this example, yeah, there was and I'm not sure how many of you remembers that, the BitPay wallet, yeah, the most popular desktop and I think mobile wallet for the Bitcoin, yeah, was completely compromised in a way that, yeah, they had many dependencies, yeah, and not even their direct dependency, but the dependency of their dependency, yeah, was like some really small library, yeah. I don't know, I don't remember which one, yeah, but it was like something about sorting array, yeah, some really small library, yeah, and the author of that library noticed that, oh, my library is used by this big Bitcoin wallet, yeah, with many users, yeah. So what I could do, I will just place some small malicious code there, yeah, bump the version, publish it, and just wait, yeah, until it will get into the BitPay wallet, yeah. And after like 6 months or a year or something like that, yeah, it got there to the BitPay wallet, yeah. And the merge code was really simple. It was like, if the balance of the Bitcoin is more than 100 coins or 1,000 coins, yeah, send private key to the anonymous server somewhere there in like one of the obscure countries, yeah. And yeah, this way, yeah, the millions were stolen. Yeah, it was like a really huge hack. Yeah, probably, yeah, still those coins. I think those coins are still lost. Yeah, nobody were able to point out to who was the attacker. there, because the author of that library probably was completely anonymous there, yeah, or he, yeah, something like that. Yeah. What else? Yeah. So this is like obviously if you are building your front-end application, you are getting famous, yeah, and the author could notice that he used his package, yeah, then you could have a problem. So you always have to watch out for this scenario. Okay, so the next one is injecting the code. Yeah, you can inject the code in many different places here. Probably the easiest one, and then I have a really good example here, is the content delivery network. Yeah, because most of the people think, oh, content delivery network, it just caches the things. Yeah, so we don't need to care about it. Yeah, and I think the places in the infrastructure, when you think that they are not important, are the best one to compromise, I would say. Yeah, nobody look at them. Yeah, so this is the best one. Yeah, and this example is from the Algorand ecosystem. My Algo wallet was a web-based wallet, similar to the previous one. But just it was run in the browser and stored private keys in the local storage in the browser. What happened is that someone compromised the content delivery network, injected malicious code that, as far as I can imagine, did exactly the same. So if the balance is substantial, send private keys to anonymous server. And it happened for the MyAlgo wallet. Millions dollars were stolen. Then and nobody was able to point out who did that. This is the worst part. The worst part. So this was the worst part, and this is the common scenario in most of the infrastructure hacks. That I will provide probably more later an explanation. So next one is like a modifying build script. So the build script, the build system, continuous integration, continuous delivery system is like something that similar to the content delivery network. It's there. It works. It builds your artifacts, etc., etc. You don't care that much about it. You don't treat it as a purity in your security procedures, etc., etc. But this is the best place to put a malicious code. To add some code. That will be executed later on the back end, on the front end. Whatever. Here the example is really prominent one. It is like from 2-3 months ago, I think. What happened is that the XZ utils is a really tiny library that is used by SSH daemon. And one of the contributors, who was probably, as far as I remember, was anonymous. Placed malicious code in the build system there in the development pipeline, and it was not undetected. Basically. So nobody checked what is that. Because it was just a build system. Later on, someone was running the SSH daemon. Running some tests on it. On the new version, and noticed that the establishing connection in this new version, it takes 400 milliseconds more. And this guy started investigating what happened. Why? What is the reason behind that? And the end, he just found out that there's a backdoor basically. In the SSH. That allowed it basically to establish connection to any SSH daemon. So really serious problem. It was discovered basically in last minute because the build the binaries of the SSH daemon was already there in the alpha and beta version of the most famous Linux distributions like the Debian, Red Hat, probably as far as I remember. So like I said, a really serious thing that that was everywhere in the news. Okay, so next one is like a telling infrastructure itself. This is kind of the umbrella term, some kind of the basket for all the things. So like if anyone will have access to the infrastructure, he can do nasty things. You should always remember to look at your infrastructure as a whole. Not only like I don't know, hosting your backend, hosting your frontend, etc., etc. Even like a GitHub itself. Make sure that let's say everyone has a two-factor authentication enabled. And force those on the GitHub settings. You can do that. Then you should have protected branches, yes, so that nobody can push to those branches only through the pull requests, yeah. So then you can notice, you can do code review, yeah, you can accept those pull requests, yeah. So you can see what the code is there, yeah. Because if you don't do that, yeah, how you will notice that someone pushed a tiny commit, yeah, with comment fix or something like that, yeah, to your branch, yeah, with malicious code, yeah, and then a couple of more commits, yeah, that will hide this one commit, yeah, yeah, probably could be unnoticed. Yeah, so this is quite important. Yeah. So next one, yeah, is like let's go to the best practices to avoid infrastructure attacks. Yeah, but before we go there, yeah, this is like obviously like probably everyone noticed right now is that most of these attacks on the infrastructure require privileged access. Yeah, so it's like, yeah, I am not that everybody of you could say that like how this could happen. Yeah, that someone got privileged got privileged access to the infrastructure. Yeah, yeah, it shouldn't happen. Yeah, but yeah, we should safely assume that most of them, I would even say like all of them, were done by the insiders. Yeah. Yeah, and then the worst case scenario is that they are it is really hard if you cannot point out who did that, yeah, because you don't have you are sharing credentials or all the things. Yeah, it's really hard to prevent those attacks. Yeah, so the best practices is like they need to take this into consideration. Yeah. So okay. So next slide, I will be listing all the best practices. Probably not all of them, but the most, I think, from my perspective, the most important one. You can track them. Yeah. See if you are following them. Yeah, and track your score. Yeah. Just for your own curiosity. Let's say that. Yeah. So the best practice is that you should treat each contributor as a potential insider threat. Yeah, this is really important because if you are doing that, yeah, and if you are doing that, and you are designing your infrastructure, keeping that in mind, yeah, all external attackers will be nothing to worry about. Probably, yeah. It's like, yeah, if you are secured against the insider attacks, yeah. Yeah, probably there will be the outsiders. Yeah, will have much harder job to do. Yeah, then you need to identify all potential attack surface in your system. Yeah, so basically go through after the webinar, probably go through my checklist, Łukasz checklist, yeah, and check all those things. Yeah, how you cover those elements we pointed out. Yeah. So this is also important. Yeah. Then the next one is like if you have contributors, yeah, all of the changes to the infrastructure, yeah, deploying the new code, yeah, updating code to the network, all of those things should be logged. Yeah, because if you do that, yeah, then the insider won't be able to pull off any attack. Yeah, because it won't be untraceable. Yeah, and he will be cut later on. Yeah, so this is important. Then this is also like super important. Yeah, obviously, two contributors should never share the same credentials. Yeah, because if you share credentials to any part of your infrastructure, yeah, you won't be able to point out who did that, because 5 people who had access to the DNS system, for example. Yeah, then there are moments in when you are developing your applications that you need some kind of the privileges, super admin rights. Yeah, let's say bug on production and you need to investigate or something like that. Yeah. But think, you should limit amount of the amount of the people, the number of the people who have access, who have super admin privileges. Probably, I would say to the one, which is a CTO. So then, if there is something bad happen, there was a hack, CTO is responsible for designing the system, so that you can find out who did that. If not, CTO will be the one to blame, probably. Either as an attacker, or the one who was not able to design the system in proper way. This probably works for a team like up to 10, 20 people, I would say. The larger probably, this is getting more complicated. Then probably, yeah, to make sure that there is no manual work in between. Yeah. There's no manual work in between. You should have a fully automated continuous integration, continuous deployment pipeline. Yeah, so that everything is automated. Yeah, there is no manual steps, so nobody can mess up in the middle of the process and hide something. Yeah, next one. Then the next slide. Yeah, is that we have during the development process, often what happens is that you need to update the build system itself. Yeah, so to make sure that you have a continuous integration, continuous deployment pipeline for your build system. Yeah, so that if there's you have engineers, they can update it on themselves. They don't need to ask CTO to update it. Yeah. This will happen This happens quite often, and this will basically slow down the full development process. Then obviously, that one needs to be updated manually. So the CTO should be only the one who changed that. The next one is like a limit your dependency, because like I said, in the BitPay wallet, the more dependency, the worse you are. And then when you are upgrading your dependencies, you need to be extra careful. It's in most cases it's a nightmare to update the dependencies. Especially the more famous you are, the more trivial you have. It's like good luck with that one. You either sit with the really old dependencies, probably with some bugs, maybe even security issues, or versus you upgrade one of your dependencies, and then you need to spend I don't know how much time looking through all looking through all the changes there, because the modern tools like npm probably gives you the ability to give me all the changes to sub dependencies when I am upgrading that one, and give me even a diff, so we can look through the dependencies, but could be massive ones, so good luck with that one, the worst case probably, And next one is the everything should be part of your infrastructure, and especially probably DNS and domain register should be part of your infrastructure as well, So if you, let's say, use GoDaddy, or GoDaddy probably is, let's say, quite good one, but still, it should be under the same infrastructure. So if you use AWS, I would probably move DNS and domain register to under the AWS. So you have everything under same roles, same users, same privileges, etc., etc. And you don't have separate accounts there. Worst case scenario, if you have only one, like I said, only one account for the changing the DNSs, a really bad one. Same with the content delivery network. I know the Cloudflare is super popular. It's like 3 clicks and you have super fast front end. Everybody loves it. But it's a problem. It's then you have to have 2 separate accounts, 2 separated sets of accounts. For both infrastructure and Cloudflare. And both AWS and the Google Cloud Platform have their own content delivery network. I will just move it there to have everything under the same roles, users, privileges, etc. And the last one is that if you are hiring or have a new CTO, the new CTO should rebuild the whole infrastructure from scratch. Because what could happen is that old CTO could be a really nice guy, etc., etc. But you never know him. He could leave either open some a backdoor for him or for someone else, or accidentally there was some kind of the things that he thought he will fix later on, but forgot, and he moved on to a different job, so and then you change your CTO, 12 months passes, and hack happened, and then who did that? Probably someone from inside the team. You check your own side team, nobody is to blame, and then you don't even think about that it was like an employee or it was a CTO from a year ago. So if you are getting traction with your application, you have a massive TVL or it's growing, and you have those practices, the best practices, you don't follow them, probably should appoint the CTO should rebuild the whole infrastructure from scratch, take back all the privileges, and rebuild everything from scratch, and give the new privileges to new users, to new contributors, and then you are probably much safer than previously, and probably that's all, And now, okay, we gave you like all the best practices, how you should do, and now it's your turn. We give you like a free things you can do right now to make sure that your security is in the good conditions, in good condition. First of all, you can use the link ulam.io/consult, to book a consultation either with me or Łukasz later this week. We can help you. We can at least try to point out how you can move with your security setup. The next one is like we prepared the best practices checklist. In form of a PDF. You can take it. You can just do your own work after this webinar. I believe we believe it will help you a lot. And then obviously, if you have any questions, I will just unmute all of you. And you can start asking questions right now. Give me a second. Where you can unmute people.
I think everyone should be able to unmute themselves. So
yes, I'm able to unmute myself. Thank you very much, Konrad and Łukasz, for the presentation. I hope yes, everybody can unmute themselves if they have a question. So please go ahead with questions.
Hey, this is Tarun, and I have a question.
Yeah, sure.
Am I audible? Yeah. Okay. Sure. Yeah. So, what about some internal infra? So, in our infrastructure, we have some internal applications like liquidation bots, and the different kind of bots that does make use of the sensitive information for transaction signing, like the private key of EOA. Do you have any special recommendation for these kind of internal application which are just meant for as a gatekeeper for a protocol or application?
It really depends, because you don't need to have any private keys stored in your backend to be still. So you can someone could still hack it probably. So for example, do you have any front end that crafts transactions?
No, so these applications are primarily or solely, to run inside the cluster, so they're not needed to be exposed outside world. So
of course,
switch?
But what they do? What they do?
Like for example, say liquidation bot. So we have a liquidation bot whose job is to, so we are basically a DeFi protocol, and the liquidation bot job is to check for any positions that are unsafe and just perform liquidation on top of that. Now, as they have to perform a transaction, we have to keep track of the primary keys or the private keys for EUA.
Yes, so for example, so if you have a bot, as far as I understand, that does that, it just liquidates positions, So this could be done by any user, So it's quite safe probably, You don't need to keep it as a super secure element, Because it doesn't do anything special, in that regard, But for example, if you have a lending borrowing protocol and you have an oracle, that provides pricing, to your smart contract, this is a completely different scenario, because you could force liquidate people there.
Manipulating the price. I got it.
Yeah.
Thanks.
Yeah, sure. Any other questions? Yeah, please. You can unmute yourself.
Please go ahead.
Hi, I have a question regarding the usage of hardware wallet. For example, when you want to go to an exchange and make a swap, for example, then you have to approve the connection from the website to the wallet, and then also give the permission to the smart contract to interact with your hardware wallet. And in this case, I wanted to know if there are some best practices to avoid, for example, some exploitation. That means that some funds are stolen also when giving the accreditation for the signing operation.
Yeah, like from the user point of view, or from the
From the user point of view. For example, I got a case, but I don't think that it's so much relevant. But for example, if you go to gate.io and you want to do a swap, then you have to approve the signing operation from the smart contract to authorize a swap. And then I got like a kind of warning saying, okay, warning, this smart contract is not audited, so there might be a risk that your funds are stolen, get stolen. So that's
yeah, I understand. Yeah, from the user point of view, it's completely different. Like, we should probably run completely different webinar. How it looks like, how the security looks like from the user point of view. Yeah, but obviously the signing up any transaction is always a risky thing. Yes, so you need to basically take any. You need to be extra cautious, yeah, when you are doing that, checking the transaction, yeah, whatever, what it does, etc., before you sign it, yeah, because it's like even the authorization could be a malicious transaction, yeah, that you are signing, yeah, so you have to be just super careful, cautious, yeah.
So meaning that if I want to do a simple swap, I will have to check. From the user point of view, I will have to check the smart contract, or at least see that the smart contract was audited in order to be sure that
yeah, exactly. Obviously, you need to trust the application you are interacting with. Is one thing, and the second thing is that even if you trust it, even if it's a Uniswap, yeah, you need to make sure that what you are signing with your either online or with your ledger device, yeah, is the thing you think you are signing, yeah. So yeah, there are at least 2 points, yeah, to always check. And then the third one is obviously the worst case scenario is that you are doing something really simple, yeah. Oh, I don't know, yeah, you go to some kind of the website, and then there's a transaction that you need to sign, yeah, for sending, I don't know, one amount, one piece of the token, yeah, worthless token, yeah, to somewhere else, yeah, and you think, oh, this is like a stupid transaction, yeah, I don't even need to think about it, yeah, yeah, this is any transaction you are signing, yeah, it could be malicious one, and it could empty your wallet, yeah, so it's yeah, so any signing action, yeah, should be really we need to be really careful.
So are there some way to mitigate the possibilities of that, or just maybe using reputationable exchanges or so, or even though it's not sufficient?
Yeah, like I said, 2 points. Yeah, reputation is one thing, but the second part is obviously making sure that you know what you are signing. Yeah, even if you use the reputable brand. Yeah, because you never know if they are hacked. Yeah, or maybe you are accidentally on the wrong application.
Okay, thank you.
Thanks.
Yeah, I have a question.
Yeah.
Yeah, Algorand is using different types of storage, like local storage, box storage, and this global storage. Is there any risk of using different kinds of storages like this? Doesn't it cause any security issue?
This question to Łukasz probably.
Yeah. So basically, with Algorand, each different types of storage, they actually have to be used in different types of scenarios, because unlike Ethereum, where you can just allocate a huge map and just put all of the data into this one data structure. You can't do that in Algorand because the global storage is limited in size. It's like a fixed amount. So you have to use the local storage if you want to store per user data. Of course, now when they invented boxes, you can use boxes for this. But in general, well, you just have to think about the trade-offs. It's really all about trade-offs with Algorand and storage. So it's not like one solution is particularly more secure than the other, but you always have to consider that if you add another type of storage to your application, there is some risk associated with it. So it's more like you're actually, if you're using global storage, local storage, then if you're adding boxes, there is a chance that you will make some mistakes. So it's like more like this way. If you use more storage types, there's more risks.
Thank you.
Yeah, sure. If you had more questions about storage on Algorand, go ahead. Yeah, well,
Yeah, we still have time. Yeah. So if there are any other
It's-
questions here from other people, yeah.
yeah, well,
Feel free to ask.
somehow with boxes, it almost looks like everything converges to just Ethereum maps, in my opinion.
I have a general question. Like, I'm actually working on this Algorand. I'm doing PhD now.
Oh, nice.
Is it possible that I can join as an intern in your lab? Like, I have to spend some time other than in other country. Like, I'm in Italy now. I have to shift to some other country for some time because it is included in our PhD program. I have to spend some time in other lab, in other research center. Is it possible for you to join in your lab?
Yeah, definitely. Yeah, we have open positions here on our website. Yeah, so feel free to apply there with your CV.
Okay, thank you.
Thanks.
Perfect. I guess that's it, right? No more questions, right? Or if not, now it's your time. Well, Konrad, Łukasz, thank you so much for the presentation. And for the audience, everyone, thank you so much for joining us. I hope you learned a lot. You know how to proceed with when you need to do an auditing. Probably start with someone doing the first step, as I could see, maybe a freelancer. Then you go to ULAM Labs. And then if you need the stamp from one of the big auditing firms, then you do that as the last step. Thank you guys so much. I'm sure we'll see you also in EBC in October, later this year. And yeah, I think that's it from my side. Konrad and Łukasz, do you want to say final words?
Yeah, well,
yeah, sure.
Thanks all for staying so long and coming to this presentation. Hope you learned some valuable insights into the topic of auditing and security of Web3 apps.
Yeah, thank you, Victoria, for having us. Yeah, and thank you all of you, yeah, for joining us today.
Thank you all, guys, and see you hopefully all soon.
Bye-bye. Bye.
Bye-bye.
Thanks, guys.